12.1a, Rules of Exponents. What is an exponent? What is the job of an exponent? Well, if we're looking at numbers, we know that the little number, like this here, is the exponent. Well, what is the job of an exponent? The job of an exponent is to tell us how many times to multiply the base times itself. So the little number here is the exponent. Sometimes it's called the power. And then the big number on the bottom is called the base. So the exponent tells us how many times we multiply the base times itself. So in this case, we have 2 to the third power, so it's 2 times 2 times 2, or 2 times itself 3 times. 2 times 2 is 4, 4 times 2 is 8. For b, we have negative 2 to the third power, so that means we're going to multiply negative 2 times itself 3 times. Well, negative 2 times negative 2 would be a positive 4. And then 4 times negative 2 would be negative 8. Negative 3 to the second power, or negative 3 squared, would be negative 3 times negative 3. So a negative times a negative would be a positive 9. All right, for D, we have negative 3 squared. That looks similar to what we had in C, but do you see the difference? There's no parentheses. So what this means is in C, it was saying everything in parentheses gets multiplied times itself. So it was negative 3 times negative 3. But in D, the only thing that's getting multiplied times itself is the 3. So we have one negative, and then 3 gets multiplied times itself. Well, 3 times 3 is 9, and then we have that negative out in front, so we get a negative 9 in D. So it's very important that you pay attention to parentheses. Only what's being touched by the power gets multiplied times itself. So in C, the parentheses was being touched by the power, so the stuff in the parentheses got multiplied times itself. In D, just the number was being touched by the power, so just the number got multiplied times itself, not the sign. For E, we have we have 1/2 to the 4th power. All right, so since the whole fraction is in parentheses, that means everything inside the parentheses, or both parts of the fraction, gets raised to the 4th power. So that means the 1 gets raised to the 4th power, but 1 times 1 times 1 times 1 is still 1. And then the 2 gets raised to the 4th power. All right, so 2 times 2 is 4, times 2 is 8, times 2 is 16. All right, for F, we have negative 1/2 to the 3rd power. Okay, let's back up just a little bit. So in B, we had negative 2 to the 3rd power. So that was 3 negatives. All right, so a negative times a negative is a positive, and then we multiply it times another negative. A positive and a negative is negative. In C, we had negative 3 squared, so we just had 2 negatives, which became a positive. So we can apply this rule anytime they're in parentheses. If we have a negative number in parentheses being raised to an odd power, then our answer is going to be negative. If we have a negative number being raised to an even power, then it's going to be positive. So here in F, we have a negative number being raised to an odd power, so we know that our answer is going to be negative. And then 1 to the 3rd power is 1, 2 to the 3rd power, 2 times 2 is 4, times 2 is 8. So we get a negative 1/8. Whenever we're told to evaluate an expression, that just means that we're going to plug something in and then simplify it. Okay, so this says evaluate the expression given that x equals -4. So we're going to take -4 and substitute it in to the expression and then calculate or simplify. Now, anytime we plug something in or substitute something in, we need to do it in parentheses. So this -4, I'm going to replace x with -4 in parentheses squared. Well, a negative being raised to an even power is going to be positive, and 4 times 4 is 16. For b, we have 2, and then in parentheses, -4 squared. We have to follow order of operations, so we're going to do the -4 squared first, and we know that -4 squared is 16. Then we multiply 2 times 16, which is 32. Okay, C is different than B because the whole 2x is in parentheses. So that means we write it like this, in parentheses 2, then in another parentheses, because we're replacing the x with -4 squared. Now if we follow order of operations, we have to do what's in the parentheses first. So we're going to multiply 2 times -4, which is -8. Then we square -8. -8 squared would be a positive 64. For D, we have negative, and I'm going to plug in -4 squared. So we do what's in parentheses first, and -4 would be +4 squared, and 4 squared is 16. Okay, for E, this negative is not in parentheses, so we have a negative, and then -4 squared. So first we're going to square the -4. We're doing this part right here first. -4 squared is positive, not 64, positive 16. But then we bring down this negative, and it makes it a -16. Exponents have different rules when we're dealing with them. The rules that we're going to talk about first are the exponent of 1 rule, the power rule, and the product rule. Or I said those in the opposite of order of the way they're listed. But the exponent of 1 rule, the product rule, and the power rule. With the exponent of 1 rule, it states that any base with an exponent of 1 is equal to that base. So, for example, in A, we have 5 to the 1 power. Well, that would just be equal to 5. X to the 1 power is just x. -2 to the 1 power is -2. We can also go backwards from that rule and say if we don't see a power, then we, like here, if we don't see a power, then it's understood to have an exponent of 1. So 5 has an understood exponent of 1. X has an understood exponent of 1. The product rule states that when you multiply the same base, all you have to do is add the exponents. The base doesn't change. So in A, we have y to the 3rd power times y to the 5th power. We're multiplying our bases, and our bases are the same. So our base is going to stay the same, and we just add the exponents. 3 plus 5 is 8. For B, we're going to add the we're going to keep the base the same because we're multiplying and just add the exponents. Well, if I don't see an exponent on a variable, it's understood to be 1. So we got to make sure that we include that when we're adding up our exponents. So now 2 plus 1 is 3, plus 4 is 7. For C, we have 5x times 3x to the 3rd. Well, if you'll remember the properties of real numbers, we can multiply in any order. So 5 and x are being multiplied, and then we're multiplying it times 3, which is being multiplied times x to the 3rd. So I can change the order of this and say 5 times 3 times x to the third, and it means the same thing. 5 times 3 is 15, and then x times x to the third, remember this has got an understood 1 on it, would be x to the fourth. So I'm going to do basically the same thing in D, but I'm just not going to rewrite it. We don't have to rewrite it like we did in C. I was just showing you why we're able to multiply our different terms. So in D, let's look at the like terms. We have an a here and an a to the fourth here. If I multiply those, I would get a to the fifth. Okay, so then I have a b squared and a b. So that would give me b to the third. Then c to the third times c to the seventh would be c to the 3 plus 7, that'd be 10. All right, for E, we have 1/2 x times negative 2/3 y. Okay, so we can multiply the 1/2 and the negative 2/3. And remember, if we're dealing with, if we're multiplying fractions, we don't have to have a common denominator. So we just multiply the top times the top. 1 times 2, that would be negative 2 over 2 times 3, which is 6. And then we have an x and a y. Now, we can only add the exponents if our bases are the same. So since these bases aren't the same, we don't add the exponents. And then anytime we have a fraction, of course, we want to simplify if we can. So this would simplify to negative 1/3. So negative 1/3 x, y would be our answer. Okay, in F, there's an understood 1 or negative 1 in front of this a. So negative 1 times 3 would be negative 3. A to the 7th times a would be a to the 8th. B to the 4th times b to the 9th would be b to the 13th. All right, the next rule, or the last rule in this section that we're going to talk about, is the power rule. Well, the power rule says that a power raised to a power, or if we have a power raised to a power, then we multiply the exponents. So this is different than the product rule. In the product rule, we were multiplying the bases, so we added the exponents. Now we're raising a power to a power, so we multiply. In A, we have y to the 4th raised to the 3rd power. So we just multiply these numbers and we get y to the 12th. In B, since our fraction is in parentheses, each part of the fraction is being raised to the power. So x squared to the 3rd power, 2 times 3, that would be 6, over y to the 5th to the 3rd power, 5 times 3, that would be 15. All right, for C, just remember, anytime we're applying these rules for exponents, those rules only apply to the exponents, not to the bases. So we still have to do the base, or treat the base just like we always have. 2, the big number, our base, 2 to the 4th power. 2 times 2 is 4, times 2 is 8, times 2 is 16. So when we raise the 2 to the 4th power, we get 16. But when we raise the exponent to the 4th power, we just multiply. So that would be y to the 8th. So make sure you apply those rules only to exponents. Okay, so for D, we have negative 2a to the 5th raised to the 3rd power. All right, so our negative 2 to the 3rd power, remember, if we have a negative number raised to an odd power, it's going to be negative. So it's still negative. 2 to the 3rd power would be 8. And then for our variable, when we raise a power to a power, we multiply. 5 times 3 is 15. Okay, so then for E, since it's in parentheses, every power in parentheses is being raised to the 7th power. So we're going to multiply, and we get x to the 14th. That doesn't look like a 14. Y to the 35th, 5 times 7. And then Z, that Z is understood to be to the 1 power. 1 times 7 is 7. And then our last one for this lesson, remember we don't apply the same rule to the big number. So 3 to the 2nd power, or 3 squared, would be 9. But then we multiply the exponents. When we multiply 6 times 2, we get 12. And then 3 times 2 would be 6.